this is Vivek, and today in this video I'm going to discuss upon this important topic, like why we are given warnings like don't operate electric switches during LPG leakage. What are the possible reasons? What are the hazards? In this video I'm going to describe all about them. So the main reason behind such kind of warnings that we see is the nature of loads that we are using in our household application as well as in industrial sectors. The type of load that we use mostly is the inductive load. We are using fans, we are using blowers, we are using pumps, we are using fluorescent lamp and many other kind of devices. Most of these devices contains inductor. Okay, and that's why these loads are called inductive loads. So let us have a look a bit at an elementary circuit of a inductive load. Here you can see this is an AC supply, this is a switch S, this is the inductor L, and this is resistor R. Okay, so this whole constitutes a inductive load. Now what is the nature of inductor? The nature of inductor is that it opposes certain change of current, or it opposes the flow of current through it. Okay, so how does it work? Let's see at the Lenz's law. Okay, you must have been knowing about the Lenz's law. It says that the induced EMF within an inductor is directly proportional to rate of change of current. Okay, so this is the famous Lenz's law. Okay, E is the induced EMF, that is EMF across the inductor. L is the inductance. Di is change of current. Dt is the change of time. Let's say when we put let's say if the machine was operating at a motion, this switch was off at like closed. Okay, this switch was closed. Now this is operating in there is a stable operation. Now at a certain instant of time we open the switch. Okay, we open the switch. What happens? There is a change of current. Let's say there was I ampere of current flowing at the stability mode, and suddenly because we turned off the switch, the current changed to 0 ampere. So what is the change of current? How much is the change of current? It's almost I ampere if we neglect any kind of loss. Okay, and how much time is taken by the switch to go from on to off position? Okay, that is the time of change of current. Okay, so we can say that let's say how much time it takes. It takes almost 0 seconds. Okay, like how much time we take to change the switch position? It's 0 second or few microsecond. We can say that as 0 seconds. So change of time dt is 0. Okay, if we try to find out a ratio between them, di upon dt, the change of current with respect to change in time. Okay, so di upon dt is infinite, because it will be I upon 0, anything upon 0 divided by 0 is infinite. So L di dt, eventually what it is going to be, E is equal to minus infinite, because L multiplied to infinite is infinite and we have a minus here, so it's infinite. So what does it say is that when we are going to put off the switch, what is going to happen across the inductor? The inductor will have a high voltage, very high voltage. In practical sense, it will be few thousand volts as an impulse, and it will have a minus negative polarity, which means if let's say the supply has a polarity of plus here and minus here at that instant of time, the inductor will have minus here and plus here. Okay, now because of this, what is going to happen? This switch is open terminal, and infinite voltage will appear over here, because we know from the network theorems that at open terminal what happens, the voltage which is there appears over at the open terminal. Let's say there is a battery of 10 volts. Okay, like 10 volts, and there is an open terminal over here. So how much voltage is going to appear? Same 10 volt is going to appear. Just like that, the infinite voltage, irrespective of what the voltage of the supply is, the infinite voltage is going to appear at the open terminal with plus here and minus here. This voltage is very high. As I said, it's few thousand volts, and this gap between the switch is very small. So what is going to happen is the gas in between or the air in between this gap is going to ionize. Okay, and eventually what will happen, a spark will appear. Okay, this spark is really dangerous because this can cause inflammable gas like LPG to catch fire, and there will be an explosion. That's why we are warned not to operate any kind of switch when there is an LPG leakage in home or in any other place. So you must have noticed that when a pump or a fan, when you are going to, or any bigger load, when you are going to switch it off, you will see that a small amount of spark appears behind the switch. This is because of the same reason, because of the nature of the inductor, a spark appear behind the switch. Okay, so that's why we are warned not to operate any kind of switch when there is an LPG leakage, because that may cause a catastrophic fire all around. And to avoid such things, we are warned not to operate any switch. So here you can see the the picture of a spark which appears. This is the contact point, and you can see a spark is appearing over here. Okay, so thanks for watching. I hope you have liked this video. If you like this video, like, comment, share, and subscribe to our channel to stay updated with more such interesting topics on electrical engineering. So this is Vivek Choubey signing off. Thank you.